Hi friends, welcome to Mega Technical Hub. Today I will take you through some of ISO standards to assess the severity of vibration of rotating equipment. So I will discuss about the acceptable limit in vibration monitoring. I will also cover what should be the best method to set alarm limit for overall vibration level. If your machine is running with higher vibration above acceptable limit, then it would reduce the life of machine components. If the rise in vibration is because of misalignment, then it would damage the seal. Also, it would damage the bearing. If the rise in vibration is because of some bolt looseness, there may be some looseness in the pedestal. And if you run the machine for the longer period, then it would result in catastrophic failure like this. And if your machine is having higher vibration because of some unbalanced masses and machine runs for the longer period, then there would be a bearing fatigue. So vibration is nothing but it is a response of a system. Means change in any machine behavior, it directly reflect the in vibration. So we need to measure the vibration amplitude in vibration monitoring methodology. So it would be topmost priority for any mechanical or any electrical engineering to understand the machine behavior. So to keep the machine healthy, you need to set the vibration alarm and machine should run with least vibration level. I will cover in the next slides. For any vibration analyst, he should understand how much vibration is too much for his equipment. In industries, general guideline followed is ISO 10816. This guidelines has 6 parts. Part 1 to part 6. Part 1 it represents the general guidelines for the vibration measuring. Part 2 is mainly for the land based steam turbines generators in excess of 50 megawatt with normal operating speed of 1500, 1800 and 3000 and 3600 rpm. And most of the industrial machines they fall under this part 3 also. It has a criteria that nominal power it should be above 15 kilowatt and nominal speed between 120 rpm to 15,000 rpm, and the measurement is done at CTU means at site location. Part 4 is a gas turbines sets with fluid film bearings. Means fluid film bearing means journal bearings. Part 5 consists of machine sets in hydraulic power generating and pumping plants. And part 6 is for reciprocating machines with power rating above 100 kilowatt. For any industries and paper industries, steel industries, cement industries, all manufacturing industries they follow majorly for ISO 106 part 1 and part 3. Part 1 is the general guidelines. Part 3 is for some having some criteria that I will explain in the later slides. ISO 10816 part 1 is a general guidelines document. It is a basic document which describes the general requirement for evaluating the vibration of various machine types. In vibration part 1 10816, the vibration measurements are done on the non-rotating parts. Means the vibration is measured on the housings that is non-rotating. It is very near to the bearing location. And vibration velocity in mm per second is a measuring parameter. Also it is in RMS. And the frequency range generally used in ISO 10816 is ranging from 2 Hz to 1000 Hz. In part 1 of ISO 10816, it broadly classified as 6 types: class 1, class 2, class 3, class 4, class 5. And these all 5 classes are mainly based on the kilowatt of the machine. For the class 1 machines, it includes the machines up to 15 kilowatt power. If the machines are running below 0.7 mm per second and the machines are below 15 kilowatt, then it is treated as good equipment. If the vibration is around 0.7 to 1.8 mm per second, then it is treated as satisfactory. If it is under 1.8 to 4.5 mm per second, then it is treated as unsatisfactory. And whatever the vibration limit, it is more than 4.5, then it is treated as danger zone. We should not run the machine above 4.5 mm per second for the class 1. In class 2 machines, it includes mainly the medium sized machines. Here mainly the two major criteria are followed in class 2. First one is capacity from 15 to 75 kilowatt without special foundation. And second criteria is the machines having capacity up to 300 kilowatt power on special foundation. Both criteria 1 and 2 comes under class 2. In this case, 1.12 vibration limit, it is considered as good, and ranging from 1.12 to 2.8 is satisfactory, 2.8 to 7.1 is unsatisfactory, and above 7.1 is treated as danger zone. You should not machine running in this above 7.1 mm per second. For class 3 machines, it includes large prime movers and other large machines with rotating masses mounted on the rigid and heavy foundation. Just listen, it is mentioned as rigid and heavy foundation with power rating above 300 kilowatt. In class 3 machines, if the vibration is below 1.8 mm per second, then it is treated as good equipment. If the vibration level from 1.8 to 4.5, then it is satisfactory. For 4.5 to 11.2, it is unsatisfactory, and above 11.2, it is treated as danger zone. So some of the conveyors and the instrument like cement ball mill, they all comes under class 3. In case of class 4 machines, it also includes the large prime mover and other large machines. But here difference is the rotating masses are mounted on the soft foundation. Earlier it was class 3, it was rigid foundation. Here it is soft foundation with same power rating above 300 kilowatt. Because in vibration amplitude response, you all know it is directly proportional to the dynamic force and inversely proportional to the dynamic resistance. Whenever the dynamic resistance is low, then you have the higher vibration amplitude, but the force will be the same. So in case of soft foundation, as the dynamic resistance is lower, so you will have some higher tolerance limit for the class 4 machines, because here below 2.8 mm per second is treated as good, but in case of class 3 for the rigid foundation, it was 1.8 mm per second. In case of satisfactory, the vibration level is from 2.8 to 7.1. For unsatisfactory, 7.1 to 18, and the danger zone is more than 18 mm per second. In class 5 machines, it mainly includes the reciprocating components, reciprocating equipment. Here mainly the drive system with unbalanceable inertia effects. So because of reciprocating masses, they have some higher vibration ranges, acceptable limits. For this good machine, they have vibration below 7.2 mm per second. For the satisfactory, 7.2 to 11.2. For unsatisfactory, 11.2 to 28 mm per second. And for the danger zone, above 28 mm per second for the class 5 machines. So all these class 1, class 2, class 3, class 4, these are summarized in the table format. So it would be easy for you to understand clearly what should be the acceptable limit at one table form. So as I already told that its frequency range is 2 to 1000 Hertz. In case of class 1, 0.71 is the good, and satisfactory is 1.8, 4.5 is the unsatisfactory, and danger zone is above 4.5. Similarly, class 2 is 1.12 and 2.8 is satisfactory, and above 2.8 to 7.1 it is unsatisfactory, and above 7.1 is danger zone. So you can see for the class 3 and class 4 in the similar manner. What I explained in the earlier slide, we can have table format like this to understand clearly about the vibration limit for different classes of the machine. In ISO 10826 part 1, it is mainly based on the motor kilowatt and also based on the flexible and rigid foundations. One more chart, that is part 3, that is 10816. It mainly applies for the industrial machines having the kilowatt above 15 and speed between the 120 rpm to 15,000 rpm. It all comes under part 3. So already said, part 1 and part 3 are mostly used by the manufacturing industries. In part 3 we have 4 groups: group 1, group 2, group 3 and group 4, and these are mainly broadly classified as motors having the frame size. For example, in group 1, the motors having the frame size more than 315 mm. This is a frame size I have mentioned here. If the large machines having power more than 300 kilowatt and less than 50 megawatt, if it is a rigid, then you will have for the new machines, here also categorized at the below. A for the new machines, B is machine with the unlimited long term operation, C is the short term operation, and D is the vibration results in damage. For the new machines in group 1, for the large machines having capacity more than 300 to less than 50 megawatt and the motor frame is more than 315 mm. For the new machine it is 2.3 is the acceptable limit for the rigid, and for the flexible it is 3.5. If the machine is having continuous running in the any industry, that is unlimited long term operation, and it is a rigid, then the limit also higher, that is 4.5, and if it is flexible, that is 7.1. Similarly, the group 2 having the motors with the frame size more than 160 mm and less than 315 mm, and also the medium size machines having more than 15 kilowatt less than 300 kilowatt. If it is rigid, for the new machines 1.4 is the accept limit, for the flexible it is 2.3. Similarly, if you run the machine for the longer period of time, then the vibration limit also changes. The limit, it extends to 2.6 mm per second acceptable. If it is flexible, that is 4.5 mm per second. Similarly, group 3 and group 4, this mainly consists of pumps having more than 15 kilowatt. Pumps may be radial, axial or mixed flow. If it is group 3, and again there are mainly 2 criteria here. For the pumps, one is integrated driver, integral part of the driver, or there is some external driver for the power input to the machine, to the pump. If it is external driver and is comes under group 3, a pump is having more than 15 kilowatt. If it is rigid, then 2.3 is acceptable for the new machine, and this one for the, if it is flexible, 3.5 is the limit for the vibration. And if it is a machine with unlimited long term operation, the pump is running for the longer period, and if it is rigid, then 4.5 is the acceptable limit, and 7.1 is for the flexible unit. Similarly, you can define for the integrated driver whether it is rigid or whether it is flexible. For the comparative study, I have put both part 1 and part 3 in the same slide. Here almost the vibration levels are not much acceptable, it's not much difference in both part 1 part 3. There is slight difference is there. For example, if you are having the machine above 300 kilowatt, if comes under class 3, as per ISO 10816 part 1, 4.5 is the acceptable limit, that is satisfactory. Okay, and it is, if it is in rigid foundation. If it is soft foundation, again 7.1 is the acceptable limit. Similarly, you can compare for the part 3. I think there is some slight differences there. For example, here large machine, if it is more than the 300 kilowatt, because considering the machine with 500 kilowatt, then if it is rigid, then again here 4.5 is the acceptable limit. If it is flexible, then 7.5 is the acceptable limit for the flexible foundation for the 500 kilowatt machine. So there is slight difference in all the levels. So you can refer either part 1 or part 3. Part 3 has some specific criteria is there, above 15 kilowatt and 120 rpm to 15,000 rpm. Machine should fall in that category. And this ISO 10816 standard, this should be followed in the initial stage, because when you have the new plant installed and you have the new equipments installed, you don't have the machine history, then you need to follow the basic guidelines as 10816, either part 1 or part 3, because you don't have the history. Once you get the history, 4 to 5 months some backup data, then you need to monitor on trend basis. So trend is the best method for evaluating any machines. So for the new install machine needs to follow first initially 10816. Later, if you get the backup data for 4 to 5 months, then you need to follow the trend analysis, and you need to set a new baseline. You need to follow that baseline, because all the machines should be run below that baseline. So trend analysis is the most vital measuring for the deciding the acceptable limit. Here I am explaining one of the case study here. Suppose your machine is running with a range of 1.4 to 1.6 mm per second. Suppose your machine is having 500 kilowatt and runs with the 1500 rpm. Okay. As per class 3, the acceptable limit is 4.5 mm per second. It is satisfactory. Okay. As per your trend, any variation below 4.5 is satisfactory. But here your machine after installation running with 1.6 mm. Suddenly, if you find any jump in vibration for 1.6 to 3 mm, then there may be some external force. It resulted in the machine to increase the vibration from 1.6 to 3. That is double of the vibration. So it is a critical danger zone, because you have the change in machine behavior. Because if any machine behavior changes, then vibration also changes. As per vibration 10816, it is less than 4.5. But here 3 is also less than 4.5. But there is sudden change from the baseline. You set the baseline as 1.6 mm per second after trending of 6 to 7 months. Sudden there is increase in up to 3 mm. Then you need to take corrective action at this stage only. If you run further, then it will lead to a catastrophic failure. So trend analysis is the best method for defining the vibration limits. One more method is comparative method. Suppose you have any manufacturing industry, you have some pumps installed here. The operating philosophy is same for all the 3 pumps, and design is same, bearings numbers are same, make is same. But after installation, if you find pump 1 is having around 2 mm per second, pump 2 is having 2.2 mm per second, and pump 3 having 4.3 mm per second. And these pumps, I think, suppose you consider these all falls under class 3, That is 4.5 mm per second is the satisfactory zone. But here comparing of the three pumps, 1 and 2 running with a very less vibration is 2 to 2.2, but 3 is running double than that 1 and 2. So there may be a problem in this machine, because design is same, operating philosophy are same, but why this pump 3 is running very high vibration? Because there may be some defects in that pump. There may be unbalance, there may be misalignment, there may be looseness, like that. You need to find out the source for the increase in vibration. As we know that it is less than 4.5, but compared to 1 and 2 it is on higher side. So we need to take action in this case only. Need not follow the ISO standards. So for the trending and comparative method is the best method in any industries. And one thing we need to have concentration while fixing the sensor or the bearing housing or any plumber block. For example, if you fix initially, if you are taking at this point, and next month next person comes and he is taking the vibration at this location for the vertical, then the vibration differs. So measurement should be done at same location, then you get the repetitive readings. So for any machines you need to mark for the measuring locations like this, for the vertical, horizontal and axial, and in that location only you need to put the vibration sensor for the measurement, then you get the good trending analysis. So for any in trending, generally we follow that method, like if it is above 15%, then we can say the deterioration has started. Suppose it is more than 50% from the baseline. If you set a machine at some baseline and after certain years of operation it is increased 50%, then the deterioration already happened and it may deteriorate further, damages of the bearings. So need to take corrective action in this case. You need to find out what is the source. If any balancing required or alignment is required, you need to take the action by taking proper shutdown, like that. If it is suppose above the baseline, if it is increase in vibration is 100%, then what happens? Then you need to shut down the machine and need to take the proper preventive measure. Otherwise it would result in catastrophic failure. So till now I have covered all the ISO standards and what is the trending analysis you need to make, what is comparative method. Okay. So next I will cover that initially I told that one of the comment I received in my earlier sessions, that how to calculate the velocity in RMS for the complex wave, because for the simple sinusoidal wave, simple wave, that RMS is always is equal to 0.707 into peak, but this is not true for the complex wave, because in RMS generally we measured in the reverse name, because you need to you need to take the mean of that one, again you need to square root of that mean. So for example, it is a complex wave and these are the some of the samples here, N1 and N2, these are the samples here. Regarding samples and complex, I will explain in the signal processing in detail. In brief, I am explaining here how to calculate the velocity in RMS for the complex wave. So you need to square this all the samples here, N1 square, N2 square, N3 square, and you need to divide by number of samples, then you will get the mean. Again square root of that one, you will get the RMS value. So for the complex wave, in this way you need to calculate. Yeah, for maintaining, for any vibration analyst, maintaining the vibration limit, it is similar to maintaining the blood pressure of any human beings or either in sugar level also. So to become a good machine doctor, you should understand the basic concepts and you should run the machine with lower vibration range. I think you clearly understood the important topic of this accepting the vibration level, acceptable vibration level. Thank you.